Is SpaceX going to try another 33 engine test for a longer duration? And with Flight 12 being on the horizon and Pad 2's launch mount now seemingly ready for launch,
4 to 6 weeks. That is what Elon Musk just told the world. The biggest, most powerful rocket ever constructed by human hands is about to fly again. And this time, it is not the same machine. On April 3, 2026, Musk officially announced the maiden voyage of Starship version 3. A rocket standing 124 meters tall, 11,000 metric tons of thrust at liftoff, a vehicle designed to carry over 100 metric tons to orbit and bring itself home to fly again. And here is where things get really interesting. Because just 2 days before that announcement, NASA finally launched Artemis II, a mission that was supposed to fly in 2024. A $4.2 billion rocket carrying 4 astronauts around the moon on a vehicle that will never fly again. One shot. Thrown in the ocean. 2 rockets, 2 philosophies, and one of them is about to make the other completely obsolete. Let's dive in. The V3 revolution. Now, let me be very clear about something. Flight 12 is not just another test. This is not version 2 with a fresh coat of paint. Starship V3 is a ground-up redesign of the most ambitious launch system in history. The fully stacked vehicle stands at 124.4 meters, over 408 feet. That is taller than the Statue of Liberty. The propellant tanks on both the ship and the Super Heavy booster have been stretched to hold approximately 6,900 metric tons of liquid oxygen and liquid methane combined. That is almost 7,000 tons of propellant feeding 33 of the most advanced rocket engines ever built. And those engines, the Raptor 3, are where this gets absolutely insane. Each one produces 280 metric tons of thrust at sea level, up from 230 on the Raptor 2. Chamber pressure has been cranked to 350 bar. The dry mass has actually dropped to 1,525 kilograms, giving each engine a thrust-to-weight ratio of 183.6. For context, the Space Shuttle main engine, the RS-25, sits at 66. The BE-4, powering Blue Origin's New Glenn, comes in at 78. SpaceX is operating in a completely different dimension of engine performance. But here is the number that changes everything. Payload to low Earth orbit. The V2 could deliver roughly 35 metric tons reusable. The V3 is engineered for over 100 metric tons reusable. In expendable mode, we are talking about 200 metric tons. That is not evolution. That is a generational leap. Even the aerodynamic surfaces have been reworked. The grid fins on the Super Heavy have been reduced from 4 to 3 larger fins, optimizing control authority during descent while shaving off dry mass. Every single gram matters when you are building a rocket designed to fly dozens of times per year. Flight 12, the mission profile. So what exactly is Flight 12 going to do? The hardware assignment alone tells you how serious this is. Super Heavy Booster 19, the first Block 3 booster ever fully assembled, is the first stage. This thing was stacked in a record 25 days, half the time it took to build Booster 17. Ship 39 sits on top as the first V3 generation upper stage, serial number 1 of a brand new production line. And Flight 12 will be the inaugural launch from Pad 2, Starbase's newly commissioned orbital launch pad with a deep flame trench, a reinforced water-cooled steel deck, and a water deluge system that dumps 422,000 gallons of water under the launch mount in seconds. That volume is absolutely necessary to suppress the acoustic shockwaves and thermal output from nearly 17 million pounds of thrust. Now, the road to Flight 12 has not been perfectly smooth, and SpaceX would tell you that is exactly the point. Booster 19 passed cryogenic proof testing in early February. Ship 39 completed 3 rounds of cryo tests by March 5th, but during a static fire attempt on March 16th, the test aborted after approximately 1 second due to a groundside issue during engine startup. That is why the window has shifted from April to early to mid-May 2026. And here is a critical detail. SpaceX is not attempting a booster catch on this flight. No Mechazilla arms, no ship recovery. Musk has explicitly said catches are deferred to flights 13 through 15, depending on how well V3 performs. This is pure baseline validation. Clean data on an entirely new airframe before adding recovery complexity. The upper stage will target an ocean splashdown rather than full orbital insertion. The FAA launch license is still pending as the agency evaluates final anomaly reports from Flight 11 and updated safety data for the V3 vehicle. but SpaceX has already secured FCC Communications Authority running through October 2026, a clear signal that the technical side is ready. Now, before I show you the numbers that are going to make your jaw hit the floor, the side-by-side cost comparison that proves just how unsustainable NASA's old model really is, make sure you are subscribed with notifications on. We are covering every single Starship Flight and Artemis milestone as they happen, and you do not want to miss what is coming next. Stay curious and keep exploring. The Artemis II reality check. Now, let me be fair. Artemis II launched. On April 1st, 2026, 4 astronauts, Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian astronaut Jeremy Hansen, lifted off from Kennedy Space Center aboard the Space Launch System. Today, April 6th, marks Flight Day 6 of their 10-day mission. The Orion spacecraft just broke the human distance from Earth record set by Apollo 13 in 1970. That is genuinely historic. But here is where things get uncomfortable. This mission was originally supposed to happen in late 2024. Then it slipped to September 2025, then April 2026. And the reasons for those delays tell you everything about the fundamental problem. After the uncrewed Artemis I flight in late 2022, engineers found unexpected charring and chunking of the Orion heat shield. Not uniform wear, actual chunks of ablative material breaking away during re-entry. That consumed over a year of engineering analysis. Then they discovered flaws in the battery systems and life support redundancy that required complete component swaps. And as recently as February 21, 2026, just weeks before launch, the fully stacked SLS had to be rolled back to the vehicle assembly building because of an interrupted helium flow to the upper stage, traced to a ground-to-rocket interface valve. And the cost. The total development cost of the SLS program has reached approximately $31.6 billion, and that excludes the billions spent separately on Orion. The NASA Office of Inspector General estimates the actual per-launch cost of an Artemis mission at $4.2 billion, not $2.5 billion as originally projected. $4.2 billion for a rocket that flies once and sinks to the bottom of the ocean. The numbers do not lie. Now see, this is where both sides of this debate get stunned, because the timeline comparison is absolutely brutal. Between the launch of Artemis I in November 2022 and Artemis II in April 2026, NASA flew 2 missions in 3.5 years. In that exact same window, SpaceX executed 11 full-stack flight tests. They went from literally destroying their own launch pad on Flight 1 to catching a super heavy booster out of the sky with giant mechanical arms on Flight 5. They lost vehicles, they blew things up, and every single failure made the next flight better. That is the test fly fix methodology in its purest form. Now look at the economics. SLS costs an estimated $4.2 billion per expendable launch. Current expendable Starship costs hover around $100 million. Musk's stated goal for a fully reusable system is between $2 and $10 million per flight. Even if you factor in the orbital refueling architecture, which analysts estimate could require 10 to 15 tanker flights at roughly $40 million each, totaling around $600 million per lunar mission, Starship is still nearly an order of magnitude cheaper than throwing away a single SLS core stage, and NASA's own leadership knows it. Administrator Jared Isaacman, the billionaire astronaut who commanded the Inspiration 4 and Polaris Dawn missions, before being confirmed as the 15th NASA administrator in December 2025, said it publicly. He called SLS, quote, not the most economic path, and certainly not the forever path for deep space exploration. That is the head of NASA telling you the agency's own flagship rocket has an expiration date, the Artemis Overhaul. But here is where things get really interesting, because Isaacman did not just criticize the old model, he blew it up and rebuilt it. On February 27, 2026, NASA announced a sweeping overhaul of the entire Artemis program, and the most shocking change was this. Artemis III, the mission that was supposed to return humans to the lunar surface, has been stripped of its landing objective entirely. Instead of going to the moon, Artemis III has been redesigned as an integrated systems test in low Earth orbit, scheduled for 2027. The SLS will launch Orion to rendezvous and dock with commercial landers, SpaceX's Starship HLS and Blue Origin's Blue Moon, to test life support handoffs, navigation systems, and the new EVA spacesuits in microgravity before committing to a lunar descent. Isaacman compared it directly to Apollo 9, which tested the lunar module in Earth orbit before Apollo 11 went to the moon. His reasoning was straightforward. Jumping directly from a flyby to a landing was, quote, too big of a gap. And he was backed up by NASA's Aerospace Safety Advisory Panel, which issued a sharply worded warning that the original plan had far too many unproven firsts. The actual return to the lunar surface is now officially targeted for early 2028 via Artemis IV, and whichever commercial provider, SpaceX or Blue Origin, demonstrates readiness first during the Artemis 3 tests gets the landing contract. That is a billionaire space race within a government program. To hit those targets, SpaceX needs to nail orbital refueling. Internal documents suggest they are targeting June 2026 for the first full ship-to-ship propellant transfer demonstration in orbit. After that, an uncrewed Starship lunar landing is targeted for June 2027. And all of this is being funded by the One Big Beautiful Bill Act, signed on July 4, 2025, which injected $10 billion into NASA's budget, 90% dedicated to human spaceflight. Isaacman called it the largest supplemental investment since Apollo. The collision course. But even with all this momentum, there is a brewing conflict that could derail everything. And it is a philosophical war between Silicon Valley automation and traditional aerospace doctrine. Aerospace journalist Eric Berger reported a formal disagreement between NASA and SpaceX over the landing protocol for Starship HLS. NASA's human rating requirements demand that crews have manual control capabilities during a lunar landing. SpaceX is pushing back hard, arguing that their automated landing systems, driven by complex software making millisecond adjustments to engine thrust and landing leg deployment on unprepared lunar terrain, are vastly superior to human reaction times. A March 2026 NASA OIG report flagged this as a worsening trend. If it is not resolved before the critical design review, SpaceX may need to request a safety waiver or face costly schedule-killing redesigns. The irony is staggering. During Apollo 11, Neil Armstrong had to grab manual control to dodge a boulder field while the guidance computer threw overload alarms. In 2026, modern avionics far exceed what any human pilot could do in those conditions. But NASA's regulations are still anchored in 1960s piloting philosophy.